Hello, question 9. Are you recording? Yes, you are. That's correct. Oh, but it's wrong completely. So now you see that should be a plus. And the reason for this is that last year's exam questions were all wrong. Well, not wrong, but the students all learned the objective row with the opposite signs to what you're learning. So whenever you see a model solution, well, you have to be tolerant of various things occurring in the objective row. Thank you. So if the right-hand side changes, what changes in the final tableau? Only. Val? Didn't have influence on anything else. And this. So how do you get the new values? Yeah, one way of doing it is look at the difference. So it's changed by 40. Of the second constraint. So you have to take 40 times this and add this. Oh, this. Okay. And like that, you get minus 20, 50. And 100. I think. So what's next? Yeah. Got to dual pivot. Why? Because there's a negative number in the val column. Oh, yes. There's a negative value in the val column. You have to dual pivot. Where do you dual pivot? So what's the process to determine where you dual pivot?
One's in that row yeah, the ones in that row
You go through that row?
Divided by the ones in the objective.
No. And what do you look for in that row?
Negative value.
Negative values. There are two. That's going to be one of them. There's no negative values. There is not a single negative value in that row. You can say that the problem is not feasible and stop. That's what it is. If there is a negative value and you want to maintain this kind of, it's called dual feasibility, so the optimal criterion that there's nothing negative in the objective row, you do the ratio test. And the ratio is 1 divided by 1, say, and 2 divided by 1. So the ratio here is 1. That's the ratio here is 1, and here it's 2. Everything clear? Aisha? Yeah? You sure?
Yeah.
Okay. And the smaller ratio, the smallest ratio among all, gives you the pivot element. Okay? And the pivot step, even though it's called a dual pivot step, it's actually the actual pivot step is just exactly the same as normal. You can use Excel, or you can use MATLAB, or you can use whatever you want to get the values in the exam. So S1 gets replaced with X2. Pivot element is -1, so this is just times by -1. Now, 4 times this row added to this row is -30. 1, 0, 19. -3. 80. 0, 6, 1, 1. Am I right? Excellent. Okay, so what's next? Repeat. Exactly. What's your pivot element? This one. Why? The only negative number in that row. Oh, that was supposed to be green. Okay. Do you want to see the end result? What's the end result? I don't know who came up with this. Okay, the rest I don't know. Too hard. So apparently it's 10, 1/3, 1, 4/3, 1/3, 0. And the objective row is 70.
It's 37 on the 3. And some more.
Minus.
Oh, mine are all negative because
Yes,
the negative will be.
That one's okay. Primal feasible. There's nothing negative there. Dual feasible. Or optimal if you like, because there's nothing negative there. Done. Any questions? Really simple. B. No, it's not B, it's 2. You probably add like another level. 1, and what's next? So you've got 9A, 1, and then it should be like alpha. And there will be 2 marks out of 20 for getting the numbering. So, sorry, right-hand sides go back where they were. The coefficient of x3 changes here. The coefficient of x3 changes from -3 to +2 in the objective. So what's going to change here? The objective row only. Why is that?
Because we can do both the matrix. It's only the objective row that has the C, which is the.
Okay. Do you remember there were 2 different cases for changing the objective or changing an objective coefficient? Not really that. No. Anyone? You won't be happy at all. Yeah, so there is a distinction, a slight difference between when you're doing a basic variable and the one that is not in the basis. Because if it's in the basis, then there's a bit more work to do. There's the CB thing that appears throughout, kind of. And this one is not in the basis, is it? So it's x3, which is not in the basis. So that's the easier case. And so in this case, really only what changes is just one entry in the tableau. It's just going to be different in here. Everything else is the same. And there, what was +1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 up by 5, so we have to go down by 5, I guess. Because you're starting with the negative of the objective coefficient in that tableau. So if the objective coefficient goes up, then your objective row goes down. So you get 1 minus 5 is minus 4. And so now what? Is this it? No. What do we need to do? Just by observing the audience here, I realized that if you want to do the table using a ruler, you'd be twice as slow than if you just do it by hand. Okay. Do what you want. It's your exam. Already got a degree. Okay. So what do you need to do now? Oh, it's boring. Where do you need to pivot? There. Which row? You're doing the ratio test. Oh no, why?
No.
You need a positive pivot element in this column, so it can't be anything else than this one. So S1 replaced with X3. First row divided by 5 is 4, 0 minus quarter. What? By 5? By 4? And the rest of it. Don't know. Apparently 14, 1. 8. And the objective is 36, 0, 1/5, 0, 4 bits, and 6. Okay. Oh, so for completeness, because it says determine the new optimal solution, you should say new optimal solution. X1 is 14, X2 is 0, X3 is 4, Z objective is 36. Slack, I'm not too bothered. Okay, and same thing should have happened in the previous question. So. What I was writing mistake. Okay. Any questions? Like, when can we go? Didn't want to walk in front of the camera. Okay, one. What's the question? We're deciding which projects to invest in. At most 3 of the projects. What would you write? Alice, you look happy. Got the answer.
Some like J ones, yeah.
Equals 1.
Oh, 3.
Equals 3.
That's something.
Yes, plus 2 equals to 3. Exactly. Okay. Well, get the idea. Just be careful what it actually says. 1, 2, 3, less than. Okay, 2. That one's interesting because they do project 1, they also have to do project 3.
It's less than.
So these implications are done. You got the handout at some point with logical constraints. What this does is that the only thing it really does, if they are 0s and 1s, the only values that are not allowed is delta 1 being 1 and delta 3 being 0. Which is exactly when the implication is not satisfied. When you're doing project 1, not doing project 3. Yeah, that's it. And out 3. Yeah.
Delta 3 plus delta 4 less than.
Why is that? Do you have a better answer? Sorry? There's another one, which is 1.
It's the only thing that can't happen is the.
So okay, so some wrong answers. Delta 3 is not equal to delta 4. And that is wrong because this means that they have to do exactly 1 of them, not at most 1 of them. Because this means I have to do exactly 1 of what? object 3 and object 4, because it also does not allow them both being 0, which the question does allow. So that's one wrong answer. Anybody else have a wrong answer? I have another one. Delta 3 times delta 4 equals 0. Why is that the wrong answer?
Not linear.
Exactly. This is not linear. So wrong because linear constrained, you can't. You just have. You don't have powers of decision variables, and you don't multiply decision variables with one another. You just take a multiple of a decision variable and add them together. So that's what's wrong with it. Otherwise, it does it does the job, but it's not linear. This is a way to express it. So it's only false if they're both wrong.